Hello to everybody. Welcome to today's webinar, a partner webinar of Autodesk and Idea Statica. I hope you can all hear us. We are using GoToWebinar. If anything goes wrong, it's on the ribbon on the right. You can either adjust your audio settings or type in any questions you have. We'll be covering them during the whole webinar as well as the end. Allow me to introduce the speakers. It gives me great pleasure to announce Udo Hedicke, Product Manager Structural Steel at Autodesk, and my colleague, Product Engineer Adam, myself, Juraj, also from Idea Statica. We prepared content for today in two regards. One is an overview of the connected workflows at the BIM table, and then we'll pick two examples from them, and we'll take a closer look how to do code checking, structural design of complex steel joints. So first one will be from Revit, second one will be from Advanced Steel. We'll be switching mics. We will cover all your questions after the end. Kindly spend 30 seconds on filling out the short survey. We will send a recording of that webinar as well. And for more information, do not hesitate to contact our website. We have a dedicated section on the partnership with Autodesk as well. Let's jump right into the content. We will kick it off with a presentation of Udo, who will elaborate on the connected workflows today, how it all works, and how you can benefit from that.
Thanks, Juraj, and good morning as well from my side. Yeah, as you said, I'm Udo, and I'm product manager here at Autodesk for structural steel. So basically here at Autodesk, we are on the path of connected BIM. I mean, we all know that BIM allows for earlier design, insight, and decision making, allowing changes to be made when it's less costly. Because BIM automates the production and coordination of much of the design and construction documentation needed on a project, structural professionals like you can spend more time on design and modeling, like finding the best solution for a challenging steel connection situation, while the need less time on tedious, resource-intensive tasks. Connected BIM. Here is BIM plus the power of the cloud. It's a cloud-enabled, intelligent, model-based process that unites the design, build, and operate segments. We are doing this connected BIM because we are already seeing some incredible changes in the structural industry and a number of trends that are tightly connected to how teams are using technology. Some of these include owners realizing the benefits of BIM and the associated project savings, leading to more BIM mandates and the advancement of new standards supporting BIM maturity, national BIM standards, and LOD requirements across the world. As optimized designs include greater detail, there is an explosion of data produced by BIM projects with higher fidelity at a greater frequency than that of 2D information, especially with increased computational power. Technology is removing barriers to collaborate across distances. Teams are assembled across different offices and geos representing larger talent pools. These trends are causing engineers to extend their services downstream and fabricators and installers to extend their services upstream. Teams are relying more and more on data to communicate. Our Autodesk portfolio of BIM technology supports end-to-end workflows across the building disciplines from the project's conception to completion. With our tools, you can begin BIM workflows even at the conceptual stage of structural design. Both conceptual design and analysis tools are built right into our BIM authoring applications. In addition, our solutions are interoperable and help you move from one phase of the structural delivery process to the next, so that you can seamlessly collaborate from your structural design through the construction phase of your project. Next, I want to talk quickly on a customer project where connected BIM was key for project success. The Louvre Abu Dhabi, which opens pretty soon, will be a unique museum where artwork from around the world will be showcased at the museum, with particular focus placed upon bridging the gap between Eastern and Western art. Its approximately size is 260,000 square foot. Also, this is another iconic project where clients used Autodesk solutions like Revit and Advanced Steel to increase productivity on a complicated project. The Vienna-based engineering office Wagner Biro used Advanced Steel to detail the steel on the museum's complex dome, which was designed with 7,384 unique star-shaped features. Advanced Steel helped them to work with the engineer from the very beginning of the design process, so they created a 3D model in an elevated state in order to coordinate with them. While there are many benefits of disconnected BIM, we will focus today with Idea Statica on the analyzing and verification of structural steel connections. During this stage, structural engineers and detailers have access to tools that allow them to perform, for example, a seamless connection between design and analyze. So let's give Adam some time now to highlight the great workflow that exists already between Idea Statica and our Autodesk solutions.
Okay. All right. I hope you can hear me. And greetings once again. Welcome to our session. And I'll be showing you two examples, as Uri said before. I will start right away with the Revit link example about the export of one joint of this model that I have in Revit. This is a steel structure, a steel hull, and I'll be exporting one of those joints here into Idea Statica connection, and we will calculate that joint and check it according to codes. So since you install Idea Statica, it integrates into your softwares. We support many of them now, for example, Revit, Advanced Steel, and so on. You can check that on our webpage, and let's do the workflow right now. So here on the bar on the ribbon, you just pick the Idea Statica command, and let me see, there is something wrong with that. I'll try to fix that. Okay. Seems that it doesn't want to go now. Okay, I will restart the application, and in the meantime, I will show you the link with Advanced Steel that I wanted to show you before. So as a second example. So let's start with Advanced Steel now. And this is a steel hull model in Advanced Design as a CAD software. So let's export that to Idea Statica. For that, we use a command, which is a command concheck. And this we type in, and it asks us to select the node of the joint and select members of the joint that we have 4 here. And this truss roof joint, and we select the items like plates, bolts, and welds. And now this joint is being exported to Idea Statica, which opens immediately. And here we can see the joint imported.